Good morning. So today's topic is physical properties of dental materials. We will be discussing around the following contents. What are the physical properties? Abrasion and abrasion resistance, viscosity, structural and stress relaxation, creep and flow, color and color perception, thermophysical properties, tarnish and corrosion. So what are the physical properties and why it is important in what is the importance of it physical properties in dentistry? Physical properties are why it is important in industry. We whenever we give any restoration like any if suppose if it is a normal amalgam restoration or a full crown or an FPD or a complete denture, we should be knowing the physical properties of the material which we are giving the patient. So we should be knowing what are the physical properties related to that particular material. So physical properties are based on the laws of mechanics, optics, thermodynamics, electricity, magnetism, atomic structure, and nuclear phenomena. For example, Q value, chroma. These are the physical properties that are based on the laws of optics, and thermal conductivity, coefficient of thermal expansion are the physical properties that are based on the laws of thermodynamics. So in dentistry, why it is important, what is the importance of physical property? As I mentioned earlier, physical property, we should be knowing any material which we are placing in patient mouth. If we are giving any restoration, we should be knowing the physical properties. What are the flow characteristic of that particular material? What are the suppose optics property like hue, value, chroma. If you are giving a porcelain fused to metal crown or a PFM crown or ceramics, all ceramic restoration, we should be knowing that physical properties so that we can match the shade with the natural tooth of that particular restoration. We can match it with the natural tooth. Or if we are giving an acrylic crown, we should be knowing how what is the flow with that acrylic, or how which with what consistency we should pack the material to get the complete denture prosthesis. So effectiveness of the process we will know. If we know the physical property, we will know the effectiveness of the process, how long the restoration will last, safety limitations of the material. Also, we will be knowing, and longevity of the process, how long the restoration lasts. That also we can predict. Hardness. Hardness is a physical property. Is a being its property of being difficult to indent or cut or scratch. Simply, it is the resistance to plastic deformation or a permanent deformation. Plastic deformation, it is on an applied stress, the material will undergo either plastic deformation or elastic deformation. Elastic materials will undergo, uh, it won't deform its shape permanently. Like once you remove the stress, applied stress, it will bounce back to its original shape. That is the elastic property of a material. And plastic materials usually they tends to deform from its original shape. That is, once the applied stress is removed, the material will be uh, like permanent damage will be occurred in that particular material. That is the plastic deformation. Okay. Then abrasion and abrasion resistance. Abrasion is nothing but the wearing or grinding away of the material against any uh, material, like against friction. During friction, the grinding away or wearing away the material is called the abrasion. Resistance of a material to undergo abrasion, it is called the abrasion resistance. So in dentistry, what is the importance of abrasion? So whenever we are giving any restoration, we should be knowing uh, how that restoration will affect the natural tooth which is already there in patient's mouth. So if you're giving a like ceramic crowns against opposing a natural tooth. So that ceramic crown will have a tendency to abrade the natural tooth, that is the opposing tooth. So in this picture we can see that maxillary arch, there is ceramic crowns opposing mandibular lower anteriors, there is an abrasion of the lower anterior tooth. So whenever we are giving an opposing ceramic crown opposing a natural tooth, there will be always abrasion of the natural tooth. So, coming to the viscosity. Viscosity is another physical property. It is the resistance of a liquid to flow. Viscosity is controlled by the internal friction force and measured in poise. It is nothing but the resistance of a liquid to flow. What is the importance of viscosity in dentistry? So many material, if any restorative cements or impression paste, impression plaster, if you are mixing, we should be knowing the right consistency on which the material we can load and either make the impression, or if you are talking about cement, you can restore in that right consistency. So each and every material should be having a particular amount of viscosity. On that particular viscosity only, we will be able to use the material. Or if it is under that viscosity, if the viscosity of material is more compared to what viscosity it is supposed to be having, then again the characteristic, again restorative property, everything will change. That is the importance of viscosity in dentistry. All the cement, certain cement, DIC will be having a certain viscosity before it is filled in the cavity or an impression material. Suppose an alternate impression paste if you are using, there's a particular that manufacturer has given a particular water powder ratio so that we can achieve that particular viscosity, so that it will be easy to load it on the tray and make the impression. If it is too viscous, the impression material won't flow into the patient mouth. If it is too viscous, it will again there will be too much of flow, or the material won't record the anatomical structures properly. Okay. So according to viscosity of the material, that fluids are classified into four types. That is Newton fluid, pseudoplastic, and dilatant and plastic fluid. Newton fluid is the ideal fluid. That is the shear stress which is applied on materials proportional to the shear strain. That is again, if you are seeing in this graph, it is a straight line formed in case of a Newtonian fluid. So it's a constant, it has a constant velocity. Pseudoplastic fluid, the viscosity decreases with the increasing strain rate until it reaches a nearly constant value. Like suppose its examples are blood or nail polish. As we can see, the fluid of pseudoplastic, it is marked in the red line. Next is dilatant fluid, which is viscosity increases with increasing stress. A dilatant fluid that is marked in blue line, that viscosity increases with applied increasing stress. Okay, that's the property of dilatant fluid. Dilatant fluid viscosity increases with the increasing stress. The material becomes more rigid under stress. That is a disadvantage of dilatant fluid. Example is acrylic denture based material and sanding water. Acrylic denture based material we are using in dentistry. So that is an example of dilatant fluid. Okay. Then plastic fluid, the material which behave rigid until a minimum of stress is applied. Material which behave rigid until a minimum of stress is applied. Then it starts behaving like a Newtonian fluid. Example is in the district as example is composite restorative material. So you guys have to, if they are asking for the exam, you guys have to draw this diagram and mark what are the properties of every fluids, types of fluid you have to mark in Newtonian fluid straight line, dilating fluid how it is, pseudoplastic fluids how it is, you have to mark and write in description what are the properties of Newtonian fluid. Example, pseudoplastic fluid, same way all the other fluids you have to mention with example, and you should be knowing what is the important, how it is applied in dentistry. Next is structural and stress relaxation. As we have discussed earlier, like for any applied stress, some material will act as plastic, some material will behave as elastic. Elastic is there is no permanent deformation. The material, once stress is removed, the material bounce back to its original form or shape. And plastic materials on an applied stress, once the stress is removed, the material won't come back to its original form. It is permanently deformed. That is plastic and elastic deformation. And stress relaxation is under, uh, suppose if you are bending, if we heat and bend the inlay wax, and there will be stress concentration in that inlay wax. Once you keep that inlay wax, that bent wax into a room temperature water, it gradually it will open up. That means the atoms will move back to its equilibrium position. That is, thermal energy can move the atom, and the thermal changes can cause the atoms to regain its stress. Okay. So rate of relaxation increases with temperature. Next is creep. Next physical property is creep. Next, another one is flow. Flow is nothing but the flow is greater deformation produced more rapidly with applied forces. Flow is nothing. It's a for an applied force there will be increased the viscosity of such materials will be less. That is the flow characteristic. So creep is defined as a time-dependent plastic strain of a material under static or constant stress. Suppose in an amalgam restoration, that melting point of amalgam is very low. So under small deformation produced by relative, like if you are giving amalgam restoration in the oral cavity under constant force during mastication, there will be creep. That is time dependent plastic strain. Again, this is the application dental amalgam because it's low melting rate. Amalgam has a low melting range. So amalgam can slowly creep from the restored tooth site under periodic or sustained strain. That is, that periodic or sustained strain is the that stress applied is the constant mastication. Once you fill the amalgam, there will be constant load applied during mastication. So during that process, that there will be creep formation in the amalgam restoration. Flow, it is used in dentistry, it is used to describe the flow characteristic of amorphous materials like waxes and all. Hmm. Amalgam, again, the melting range of amalgam is slightly above the room temperature. So the amalgam has a tendency to creep under constant applied stress. Creep, it also leads to unacceptable fit of a FPD framework or constant applied force. That FPD framework, it will creep. That will cause that will cause it that finally that FPD framework might not fit onto the restored that repaired tooth. That is also an application in dentistry for creep. Next physical property is the color and color perception. So, what is color? Color is the sensation induced from the light of varying wavelength that reaching into our eye. That is determined visually by measurements of hue, value, and chroma. The physical properties of color. It is the hue, value, and chroma. Hue is nothing but the dominant color of an object. When we are seeing an object, what color our eyes perceive first. That is the dominant color. It is the hue. It is also described as dominant wavelengths in spectral distribution, like that is the red, green, and yellow. Value is defined as the relative lightness or darkness of an color in a scale. That is, value from 0 to 10 is there. Value of 0 means it is black, and value of 10 means it is white. Chroma is the it represents the intensity of the color or degree of saturation of a particular color. That is, for example, if you are comparing a lemon and with a banana, that yellow of lemon, both are in yellow color, but yellow of lemon is more vivid than compared to that banana. That is the difference between hue, value, and chroma.